Welcome to the Smart Twins podcast. Today, I'm pleased to welcome Professor Fernanda Leite as our guest. Fernanda is Associate Dean for Research in the Cockrell School of Engineering at the University of Texas at Austin. She is the past chair of the university-wide Bridging Barriers Research Initiative called Planet Texas 2050. Most of her research has been in the building and infrastructure system information, modeling, scan-to-BIM, visualization and collaboration technology, and circular economy in the built environment. At the University of Texas, Fernanda has taught courses on building information modeling, project management and economics, construction safety, and sustainable systems engineering. I believe this is just a glimpse of your background and your career journey. Fernanda, welcome to the show.
Thank you, Jimmy. It's a pleasure to be here, and thanks for inviting me.
Yeah, thanks for making the time. Maybe to kick this off with our listeners, it would be great maybe that you highlight your background a little bit more and give more information about your very interesting career journey.
Sure. I could probably go back to when I was a kid. So when I was 8, I'm originally from Brazil. My grandfather was a developer of high-rise residential and commercial construction in Brazil. And he took me to one of his job sites, and I absolutely fell in love with the chaos around construction, right? All the heavy equipment, the materials, the people. So I knew that that's the field that I wanted to work in. Fast forward a few years, my father came to the U.S. for his master's and PhD. He's an agricultural engineer. So I lived in the U.S. and in a university setting for many years growing up. And I also really enjoyed, that university life, that life as a researcher. When we went back to Brazil, when he was done with his PhD, because I had the English skills, I taught English in an after-school program. And that's where I fell in love with teaching. I just fell in love with looking at students having those light bulb moments. And I remember having a conversation with my dad saying, look, I really love teaching, this teaching experience that I'm having, but I know I also love construction. What do I do? And he said, well, maybe you can become a professor. You put the two together. And then I asked him, okay, what do I have to do to be a professor? He's like, you need a PhD for that. And I said, okay. And then so that's where that started. And so I finished my undergrad, did my master's in Brazil, and then went to Carnegie Mellon University in Pittsburgh, Pennsylvania in the US for my PhD. And that's where I got into computer-aided engineering, to computing in civil engineering. So I worked with Professor Buchu Akinji at Carnegie Mellon, and that was my first initial step into the world of building information modeling back when it was just something that was just starting. And we had this really good opportunity with a developer that was building a new building for the School of Computer Science at Carnegie Mellon. And they had just heard about this thing called BIM. And we were embedded in the project doing research. And they asked us, well, do you know what this is? Can you do some of this in this project so we can learn it? And we're like, sure. We can do some work around BIM in this project. And so I was doing work around design coordination. So I started attending all the mechanical, electrical, and plumbing design coordination meetings with the contractors. And they were all obviously doing design coordination in 2D, overlaying drawings on a light table. And I had that BIM model on the side with all the MEP systems. And of course, I asked them, would you like to transition to using BIM? And their answer was, no, right? We weren't hired for this. We don't have the skill set. But that became an opportunity for me from a research perspective, because I was able to then compare the ground truth data, that control group, which were the current process, the 2D-based design coordination with the 3D-based design coordination. So I would attend those meetings every week, 6 to 8 hours each meeting, and they would do sections and a few floors of the building. And I would go back to my office at the university and run that same clash detection in a couple of minutes and find similar, sometimes better results. So that's where my first paper that came out of, the LOD paper.
Exactly.
That's still one of my most cited papers.
I know this paper. My PhD topic was around that, and I think it was one of the first papers I read at that time. It was showing the use of LOD in really practical projects. And at that time, I was also struggling to find real data about how this can impact. Would people use LODs? How those will bring value, and how that can structure the process, because BIM is a process, and with the LODs we go through it somehow to make decisions. And with that paper, it was really very, very helpful. So Fernanda, you came from blending different kind of things from your background, from your childhood, into research and into reaching the BIM point of view as well. And then you applied it also in practice. So at that time, as you said, that people didn't have the skill set, but maybe that was around 28 or something like this, like 2008, 2010, probably.
Around that time. So 2006, January 2006 was when I started my PhD. And so that's when we started that study, around that time.
Yeah, very nice. And then you were the first to really touch this difference or understand the value of BIM, or see it, really witness the value of it from comparison to the real project. So can you tell us more about this? Like, if you continue a little bit, how that was impacting the discussion maybe with the workers on site? Did this also bring more value to their perspective on adopting maybe BIM for the next projects?
Yeah, so I think with every organization, right, there's always resistance to change. But once they get they see the value and they see how much better information they're able to get in an easier way, that's when the barrier is decreased, right? That's when it's removed, and oftentimes people will see it now, and now it's the low-hanging fruit. Every project and large owners that here in the U.S. roughly, about $20 million. Anything above $20 million, you're going to do BIM-based design coordination, because that's simply like a very clear value proposition. You want to build the building virtually first, identify all the problems, fix them before you actually go to the field, right? So very clear value proposition. So I think that became a lot of owners are creating their own BIM standard. And when a few years later, I joined UT as a faculty member. So after I finished my PhD at Carnegie Mellon, I started at UT as an assistant professor. So that's the entry-level position for a faculty member in the U.S. And so I began interacting with the planning, design, and construction group that's responsible for all the capital projects on campus. And they had this one sentence that was added to every contract for capital projects on campus. And I will quote it. This is what it said: "Thou shalt use BIM," right? And this is early 2010. They really didn't know exactly what to ask for. So this is when people were starting to think about, okay, should we ask for something more specific? We know this is valuable, but we don't know how to do it and how to implement it. And now we see organizations with BIM project execution plans, right, that are very sophisticated, that they ask for very specific things, and contractors that work for them will then create a project-specific BIM project execution plan. Yeah, so it's more, so it's evolved quite a bit. And that's also when I started teaching. I created a new BIM course here at the University of Texas. And initially it was just model-based cost estimating, scheduling and 4D simulation, and NEP design coordination. And I teach it in a modular way because with modules, it's easy to plug and play, to add new things. And then you can update one module and modify one module at a time as you're teaching it. So I've been teaching this course for 15 years. Every single offering has been different because it also keeps me updated. Keeps me engaged if I have to update these every time I teach it. I think the key, though, with the success of this course and with looking at how this has evolved, I always tell my students, like, my dream is that this course is going to become obsolete and it's not going to become needed, and we're not even going to be having this conversation in 10 years because it's part of the process, right? Why would you need like a separate thing to cover this? And that's my ultimate goal. But it hasn't happened in 15 years, but I still I still hope that we'll get there someday. But as part of that course, I have a mentoring program. So the course has, about 36, 40 students in each offering. And then I divide up the class into 8 to 9 teams. And each team partners has an industry mentor. And these are people all around, mostly in the U.S., right? And mostly in Central Texas, because I want them to go to see these projects in action, how they're doing this. So the secret, the hidden agenda for me is that way I get to know everything that's going on, all the cool projects, and I select all the cool projects, all the high rises that you think of, like the Formula One racetrack in Austin. That was a case study that we had. The Tesla Gigafactory, that was a case study that we had. So all these very high-profile projects, a bunch of the Google Tower in downtown, the Meta Tower downtown, all these fancy buildings, they become case studies, and we learn all about them. So in the last 15 years, we've grown that, and we're able to build that portfolio. And I understand what's the state of the art in industry, and we're able to then keep the course like at that state of the art, and one step ahead of what industry is doing. We've had startup companies come in and test out their software systems. So Assemble Systems was a startup, and they asked us to test it out in the class. We provided, we used it in the class, and then that was, they implemented a lot of the feedback that we gave them in those tests that we did in class. So we've done that too. So it's a super fun class to teach. I love teaching that class.
And I think, Fernanda, you did the first paper in your PhD about the LODs with the practical input, and you liked that test, and you kept doing it through the years, probably. Because all of those projects, I mean, the fun of them is really to bring the practical point of view into research as well, and then look at where people are at the moment, and how can we improve this? How can we push the boundaries even further more, and innovate further. So it's like innovating in teaching. I think this is something really very interesting to see and hear. Very good. So Fernanda, I think this is also close to the book you wrote or you brought to the market. So there is the book of BIM for design coordination that you have prepared. I'm not sure if you can tell us a little bit more for the audience to know about this book and the main message of it.
Sure. So that's, again, like as I was teaching this course throughout the years, there's not that much structured material around VDC design, BIM-based design coordination, right? Virtual design construction for owners, for GCs, for subcontractors, for designers. So that came from a desire to just have that material that we could use for teaching perspective, but also for guidance for professionals in the field.
So it's like a BIM guideline, like how would you leverage the power of BIM or the value of BIM across the process in one place?
Absolutely, yeah. So it provide that, and it's a pretty easy read. I use it in my class, and I've seen it being adopted in other universities too. It was recently translated to Korean, which was a surprise for me. I didn't even know that was happening. I just got a copy in Korean, went to one of my Korean PhD students. Hey, what is this title accurate? I couldn't understand what was written there. But it was just a fun journey, even though like from an engineering faculty perspective, right? There's no incentive to write a book, right? A textbook. And I just did that because I wanted to do that. I wanted to provide that resource from a teaching perspective. I'm passionate about teaching, and I think that's important to bring research and teaching together. And that's one way of doing that. And I also had a lot of previous work that I was able to integrate into that book. So for example, that LOD paper that you were talking about, it's in one of those chapters. I had to just rewrite it and adapt it to be less, academies, and more practical language. But a lot of work that I had published in journal papers were then integrated into that book, but with a
summarized, more practical way.
Yeah,
definitely. I mean, even thinking about the industry with using BIM and all of those technologies emerging over time. So our industry is really developing quite fast. Many people say our domain is one of the least domains digitized, but honestly, I think a lot of advancements are happening already in technology, and there is adoption and tools, functionalities, and so on. Maybe the market is taking time for to see how they can be responsible for the change or responsible for making such kind of decision. But overall, having a book with, let's say, teaching material that's helpful as a guideline is also important for the industry, because we are teaching the industry to move forward. So that's a really very helpful contribution to the market overall. And then moving from books and, let's say, teaching the market to a little bit forward. So in your research, you already touched upon many things, including AI, crack detection, facility management, the sustainability, improving life cycle. So there are a lot of topics that you touched upon. Would you maybe highlight? Let's go first with the AI part, because it's the current trend, or the currently buzzing topic in the market. So you touched upon things related to point clouds, maybe to images as well. If you can tell more to our audience about this.
Sure. So it's all sort of interconnected and part of the journey, right? So when you're talking about doing MEP design coordination, you then, at the end of the project, you have this potential to have an as-built model, right? And that as-built model, in the past decade or so, most of the time, that was the end of it, right? And it was saved somewhere, and it wasn't really used by facility managers. And so that's where I started the project. I wrote a proposal for the National Science Foundation here in the U.S., and the title of the proposal is called Living BIM. And so I call that the poetic title. And the reason why it has that title is because I see buildings and infrastructure systems as living organisms. So once they're out in operations, they're going to change over time, right? There's always renovations that happen. There's always minor changes that the users have to adapt that facility throughout its life cycle. That the design and construction phase is this tiny phase, if you think about it from a life cycle perspective of the project. So the idea with the Living BIM project is, well, what can we do to decrease the barrier of facility managers using these models in the life cycle, in the operations and maintenance phase of these facilities? And the biggest barrier in talking to a lot of people from industry is, well, we can't trust them. They're not up to date. And if we go and update it, we have to recreate a bunch of data. We have to go and measure it. It's just a lot of work to update these models. So the Living BIM project focuses on, how do we remove the human from the equation then? How can we leverage scan to BIM and reality capture technologies and deep learning to automatically update these models? So throughout the years,
we have design maybe from as planned, then it's constructed. Maybe there are some differences already to the as planned, and then we push it to operations. And then people lose trust in this when they see deviations or differences, or even when they change the facility itself. So at that point, they want to gain that trust again, maybe by capturing the as-is state or the current state. And this is why you need reality captures from your side.
Yeah, instead of just laser scanning a project and then importing that point cloud into a model authoring tool, right? And then overlaying your objects on top of the cloud of points. So that's like a manual generation of a BIM model based on a point cloud, right? So the point cloud is the accurate geometry of what's out there in the field, but we want a machine to be able to understand what those XYZ points mean, and not a human having to do that overlay themselves. So throughout the years, we've been doing different approaches, leveraging transfer learning. So there's a lot of databases out there already that have semantically segmented data sets, and they're labeled. So walls, windows, doors, simple objects that any human can interpret, right? And what we did, we added another database called 3D Facilities, and that was one of my former PhD students, Thomas Czerniawski. He created that database, and he leveraged existing databases, used transfer learning to expand that. And that's a very specialized data set with lots of MEP systems, building systems, that are harder for a layperson to label.
Maybe for our audience, the difference between transfer learning is that how your researchers looked into the real deep learning models, so really going much down into the details in comparison to ChatGPT or those kind of existing models that you just take over the shelf and use. So this is where you have this neural network, you substitute or change the last layers of it and then train it further on specialized data. And this is what kind of data that you have for your purpose.
That's a great summary. Yeah. And so with that, like Thomas was able to automatically classify 13 different classes of objects in the built environment. And that was more than twice as much what was done before his PhD research. And then we continued that area. So another follow-on PhD student, Zhangwan Ma, who has since also completed his PhD, he then used all of that data to then actually create those 3D models using generative design. So if we understand that a wall moved from here to here, right? Moved, let's say, 20 inches, or if you can translate that to centimeters to the left. You then can tell a model, okay, this is a door or a window, and they recognize that door or the window, and they use generative design to then move it to the right place.
So if we have the points type, the type of the points, what kind of object is that? And then try to also match it with the original position in the BIM model itself.
Well, not that. Yeah, the original position is what we're trying to change.
Yeah, this is the same object but moved. So then we need to move the BIM model accordingly.
Correct. Yes, and that requires, like, training these models requires a lot of work. So we do a lot of manual semantic segmentation and labeling with the help of so many undergraduate students that have worked in my group. So without that help of and that work of all these undergraduate students that are out laser scanning spaces and that are out doing the developing the ground truth data so we can train these models, this wouldn't have been possible. So hopefully in the future, I keep telling the undergrads, hopefully you're contributing to something that this work won't be needed in the future, right? And that's what we're trying to achieve.
Yeah, we started seeing a lot of startups and a lot of applications coming to the market with scan to BIM capabilities. It is still, let's say, an early stage, so we don't see that much of high accuracy or high detection of object types, maybe some windows, walls, and doors. But when we go to MEP or specialized disciplines, then it gets really complex or hard to predict. So hopefully soon we see more with the advancements happening at the moment.
And then again, like, this also connects with some of my more recent research interests, right? So over time, I was doing a lot of research in technology applied to capital projects delivery, right? So laser scanning, reality capture with different types of technology. Yeah. But then I began looking at the impact of the construction industry in our environment and doing research on construction waste estimation using BIM, right? So we have this BIM model. Perhaps we can estimate how much waste is being generated for each of these waste streams. And that also requires a lot of data collection in the field, because we have to understand in that context, in that specific project, where are those different waste streams going? Are they being recycled? Are they going to the landfill? And that varies based on the context. So in Central Texas, there are no gypsum recycling facilities. And if we had one nearby, that stream would most likely be recycled, because that's an easily recyclable material. But it's not, because the cost of shipping it to a facility, a recycling facility, would almost offset the carbon, the embedded carbon costs of that material. So looking at that, that's when I began doing more sustainability related research.
Nice, and this fits a lot, or focuses a lot on the material types, right? So the BIM model is already rich with this semantic information about what kind of material layers exist. And then from this, you can get some kind of indicator on how this will be affecting the life cycle, and how can we recycle this building maybe once we disassemble it or deconstruct it, right? So you started from design to operations. So you were saying, now we are designing and we want to see how we can use those models in operations. And then you moved further into disassembly, which took you into design, because again, the BIM model is the source of information or source of knowledge that we are trying to leverage to optimize the process. So for the design to disassembly, maybe you can tell us about the latest things you have done there and where is your research going from that direction? Because I believe this has a huge impact on the current issues we have in the industry facing all of those sustainability issues and making informed decisions even from the design phase.
Yeah, absolutely. So it all started with this construction waste estimation research, right? That we're looking specifically at different waste streams. And then in that research, and this is one of my former PhD students, Beatriz Guerra, she now works for Autodesk as a product developer. She started looking at, well, if we understand how much waste materials how much waste each material is generating, how about we look at the construction schedule and see if we can reutilize that waste from one stream, one part of the project, in another, before to minimize what ultimately leaves the project. And that's when I started looking at circular economy in the built environment, right? So circular economy is just a whole different concept. What you might think of waste could potentially be a resource in either your industry or another industry. So we're shifting that mindset from a linear economy, take, make, use, dispose of materials, to a circular economy in which that waste now becomes a resource. And so that is key there in terms of thinking about, in the built environment, how do we do that? How do we implement that? Each of these building systems could be considered, a separate circular system. And we're looking at, well, if we want to design a facility, a building, so that it can be reutilized, or so that the pieces and parts can have a second life, we need to start thinking about that early on in the design phase. And that's where that research, one of my current PhD students, Guilherme Eliotti, he's doing his research on design for disassembly. And he's co-supervised with my colleague, Chris Rauch, as well. And so we are looking at, well, how do we do that then? How do we begin designing, and what building elements and what building systems are best suited for design for disassembly? So there are types of systems that are harder to then disassemble once that facility is outdated. But there are elements that are suitable for that. And that's not just for, if you think about it, the purest concept of design for disassembly is at the end of that life cycle. And we saw that in the World Cup stadiums in Dubai, right? They really didn't need those white elephant soccer stadiums for a very long time, but they were designed to be disassembled and transformed into smaller community centers, smaller spaces. And that was great. That was thinking proactively based on their specific need. And we can also think that way too. As an owner, we saw that how the pandemic impacted the use of office spaces. We had a bunch of office spaces, and now there's no need for that amount of square footage. How do we adapt those facilities for a new use that we may not have foreseen when that building was designed and built? So allowing that flexibility is not just for when it's decommissioned and will become something new, but also during the life as needs change. Again, going back to that concept of living bin, right? Buildings and facilities are like living organisms. They change over time.
Yeah, thinking about disassemblies, I always imagine the modular discussion you brought at the beginning. I also hear modular construction. So is this also part of the equation? Because having like modularity and modular construction will maybe allow easier disassembly or unplugging things, if I go back to your first statement?
Yes, absolutely. I wish we did more of that, right? We need to do more prefabrication, more standardization, more modularization and construction. That'll speed things up. It'll create safer job sites, right? The more we can remove from the construction site, the safer the job site actually becomes. So doing less craft work in the actual construction site. And we can do that with so many different methods. It doesn't mean that we all have to look, our buildings all have to look the same, right? There's mass customization approaches that can be done. And you can still do a prefabrication to custom design in facilities and buildings. So there's so much yet to be done in this field, and modularization, again, you see a lot of it being applied to certain types of materials. And we need to push that envelope to see it applied to a variety of different materials in the field.
Yeah, this unlocks a lot of opportunities even to optimize further and do a better circular economy, accounting for circular economy and sustainability overall. So taking the living BIM title, I mean, I really love it because it's not only BIM, it's like making the BIM living. And so comparing this to digital twins overall, how did you see the connection there? Because if I imagine the core message behind living BIM and compare it to the current definitions of digital twins, I see some overlap there. Maybe when we discuss with different kind of people, they have in mind different definitions of digital twins. They can be for a specific design or construction or operation phase, but the life cycle, I think, point of view with the living BIM is really spot on. And I don't know if you can elaborate on that, or how do you see it in comparison to the new trendy buzzword of digital twins? It's not really a buzzword, it's really becoming more tangible with the days. So how do you see that?
In the built environment, I see a lot of our colleagues in our field making that differentiation between a BIM more like a digital shadow, and the digital twin has that connection to the real world via sensing, actuation, whatever it may be. But there's that real world connection to the actual physical elements that are in the built environment. And that's important too, as you're thinking about how are you going to adapt, let's say, a road, right? If you're getting understanding what loads are actually being applied to that bridge per se, that can help plan maintenance of that infrastructure system if you understand what loads are being applied over time. So that feeds back into that facility life cycle analysis that makes it more efficient. You're able to collect real world data. So I see that as the main difference. I know that in other fields, it's almost a BIM, right? A digital twin is equal to a BIM. If you look at, let's say, the aerospace industry that have been doing these types of physics-based models for such a long time, but that they are used to test the design of aircraft systems. So very similar way, but I think in the built environment, we tend to think about this connection to the physical world. Yeah.
But if I refer to your definition of the living BIM project, you try to also to connect the BIM model to the reality or to the actual reality. It's not sensors, not actuators, but it's real-time captures from the as-is state. So this is also an additional flavor or input over that BIM model to make it alive or more up-to-date. It can be maybe taking more time until we convert those point clouds into BIM or identify differences. But if you think about it, it's breaking the actual state on that digital model, which is the BIM model. I don't know if that makes sense, but I thought you were doing digital twins since a long time, but it was called living BIM, and that's very interesting. I mean, the definition of, I think, sensors, actuators, and so on is really becoming more prominent in the market. From at least from limited perspective and the different offerings we have, we always see also the value of bringing data from other systems. Like in our digital twin solution, we see the connection from facility management software or the connection from many things that happen to capture this kind of activities happening during the operation phase. We see reflecting those on the BIM model are already valuable as IoT or as sensors because they bring the actual state or the actual things happening on site. This is why I saw your definition or your living BIM story, and it just sounded to me very close to that definition. Thinking with different data sources and putting things and even representing information to users, I think the most tricky part is how do we visualize it, or how do we make people able to perceive what they see there. Things can be easily overwhelming. Putting things in one place for different kind of skilled people can be also complex or hard to grasp. So I know you're also famous in your research in that area. Maybe Fernanda, tell us a little bit more how you see the value of visualization overall.
So I think there's any model is a simplification of reality, right? And how you visualize that data will impact your decision-making process. And we wanted to test that hypothesis with comparing and for visualization of field detected issues in heavy industrial projects. If we compared, let's say if we had professionals, people with 3 years or more of experience doing design coordination type work in these facilities, how does it impact if they see the input data, if they see those clashes or those design issues in a 2D screen? They're still BIM models, right? They're still BIM. They're seeing the same thing either in a 2D desktop machine or in an immersive virtual reality headset. Well, it turns out that it really does impact the quality of your decision-making process. So if we compared, we had two groups of users, people that were, we call them the 3 years or more, people with the experts, and then the novices were people with less than 3 years of industry experience. And we had, in each of those groups, we had two groups, a control and a treatment group. The control group was walking a model that we had embedded several design errors in. And these are the types of design errors that you wouldn't capture in an automatic clash detection software system, that you literally had to walk the model to visualize. So an example would be if you had, let's say, a pipe spool that was supposed to have a support under it, right? It was a heavy pipe spool, and the support didn't quite get to the height of the connection where it should be supporting. So in this scenario here, you have a false negative in design coordination, right? But design coordination software systems are designed to catch true positives, right? There has to be some sort of geometric clash in it. So for these types of false negatives, you've got to walk the model. And if they're walking the model, oftentimes the vantage point, so how you're visualizing it, can impact how much of these design errors you actually see. For the novices, it was drastic, the difference. It was more than 2 times the number of design errors that they saw when they were using the immersive virtual reality headset, because of the angle in which you're seeing and how you're actually interacting with that model. It feels like you're in the real world. The experts didn't have quite as drastic, but it was still statistically significant, the increase in the number of design errors that they saw. So what that tells me is that if we identify use cases that we can see value, because that's the other thing that I see a lot in industry, and when people say that the construction industry is not using technology, that's so not true, because they're using all sorts of cool technologies in projects. But the issue that I see is oftentimes companies will implement a new technology, and it's almost like that shiny new toy that they want to test out. And they don't really think strategically about the use case that is supporting. It doesn't, just because you're doing it in a digital way, doesn't mean it's going to be better, right? So thinking strategically and thinking holistically across your organization of how you're going to implement this technology and in what use cases it makes sense is critical for the long-term success of implementing that technology. And we see that with virtual reality as well. It doesn't make any sense for every type of use case, but there are certain use cases that it really, really does help. And another one is safety training, right? So you're putting people in an environment that you want to train them, but you don't want to train them and put them in an unsafe situation. And so that's a really great use case for safety training, that they can actually feel that if you go into a virtual reality, you're walking a beam and then you step to the left and you fall, you feel it in your gut that you're falling. So it's very visceral, the feeling, very real. And that's something that you can't do in the real world. So having that represented virtually is important. And just one last example is, again, going back to operations and maintenance. If you're talking about complex facilities that may be, let's say, an offshore facility, right? That you people work in shifts. If some piece of equipment malfunctions and you don't have the right expertise in that facility at that moment in time, what do? So perhaps virtual reality or mixed reality can augment the expertise of people that are there in the field when you're connecting and getting input from experts that might not be on site at that given point in time. So leveraging these technologies for use cases that actually can bring measurable benefit is in thinking about that early on is critical.
It's like really architecting using technology for the purpose, not using technology, all technologies for everything, because it will be overwhelming, maybe costly, and it will be instead doing more fun things more than the value. But still, I mean, people counted maybe that it's not a good experience. We didn't see the return of investment. Maybe we should do this more. And I agree with you. We see a lot of usages of technology in the domain, and especially digital twins for remote inspection. It's really very, very, very common use case that a lot of people, especially in dangerous, also off-site facilities, it's heavily used and very, very valuable. Very good. Fernanda, if we go to, or if we come to the moment, to your current new position. So can you tell us about the vision or what you're heading towards? I know you have your research group, you're doing research, but also you are doing contribution in the university overall. If you can tell us a little bit about this, I think this would be great to hear.
Sure. So over time, I started going into administrative roles in the university. So I chaired, so I oversaw a large interdisciplinary research program called Planet Texas 2050, and that represented 30 different colleges, 130 researchers all around campus. This is many different colleges, from geosciences to planning to fine arts to engineering, all working together towards building a more resilient future. So that's when I started doing a lot of work in climate adaptation and climate resilient infrastructure systems. But that also gave me an opportunity to bring teams that are very interdisciplinary together to solve this grand challenge. And then this opportunity came about of leading the entire research mission of the Cockrell School of Engineering. So what my current role is, so I'm an associate dean for research. So in the U.S., universities are typically structured in a way that you have the president of a university and a provost. So the president would be sort of like the CEO, and the provost would be the chief operating officer that actually keeps the university running. And then under each college, you have a dean. So we have a dean of the School of Engineering. That's the highest authority in the School of Engineering. And then the dean has two associate deans that work along his side. So in this case, there's associate dean for research that oversees all of research and facilities and space and construction. And then we have the associate dean for academic affairs that looks at faculty hiring, promotions, and so forth. So it's more of a people type person. So in my role, at the School of Engineering is pretty large here at the University of Texas. We're always highly ranked. We have about 300 tenured or tenure track faculty, a total of 6,000 students. And we're divided into 7 academic departments. So civil engineering, chemical engineering, electrical engineering, and so forth. There's 7 academic units. And then we also have 17 what we call research centers, interdisciplinary research centers that also report to my office. And so these are things like the Construction Industry Institutes, right, that do research with industry through the university. And so they report to the ADR's office. And then I oversee all of space. You can't do high quality research without appropriate space and facilities. And so it makes sense that space is also overseen by the ADR. And so currently where I'm building 4 capital projects. I'm overseeing 4 capital projects in the School of Engineering, including the new home of chemical and chemical engineering and petroleum engineering, 2 large facilities that will support semiconductor research, one in our research campus and one off-site near the Austin airport. And we're gutting a large piece of a building to build new environmental engineering labs as well. So it's always quite exciting to see everything that's going on campus.
Again, building and construction. So there's always building with Fernanda.
I know. I know that's why my I'm not so super active on Twitter, but that's why my Twitter and handle is Leite Build, right? Because that's what I do. Uh, but it's a super fun job, and it's very humbling because you get to learn everything that's going on across the Cockrell School. That as a faculty member in your lane, working in your field, you don't really have an appreciation of all the broad research that's happening, from materials discovery to neural engineering. And all it's really amazing what people are doing, and the problems that people are solving, and being the person that helps them get there and enable that, and finding solutions and negotiating opportunities with other colleges, with companies is just great to see that I can help them take their work a step forward.
Great. So great stuff. I mean, it's a very interesting journey, Fernanda. So you moved again to more applied, more pushing and building and contributing. And that's really very great to see. Maybe before we finalize our talk today, what would be a final advice to our audience about how can they employ digital methods or digital tools to push their construction projects forward? So from research perspective onto the practical world, since you're doing lots of practical works, what would be your advice?
So I think it's so important to have a foot in the real world, right? So you can't do digital construction, you can't do virtual design and construction unless you actually understand the real world problems, right? So having strong ties to the real world, to actual problems that people are seeing in the field, will give you such great insights to implement new technologies in a lab or in software development, because you're actually doing use-inspired research, right? So understanding what the needs are is so important, and that's one of the reasons why I love interacting with my industry collaborators. I love seeing what's going on in projects and seeing what problems they're facing, because if they have a problem in research, oftentimes that can be a great idea for a PhD research. I've had so many PhD students come up with their the focus of their research by having conversations or by going to job sites and observing problems in the field and seeing, oh, okay, maybe we can try to rethink how this process is done. But understanding those problems is the first step, right? So that connection to the real world is so important.
Very good. So it's again like the concept of Amazon, working backwards from the customer or from the real problem, and then try to find the solution or optimize existing workflows. Very nice. And if our listeners would like to reach you out, Fernanda, you mentioned your Twitter account's not active. Is there other kind of platform that they can reach you?
I do have a Twitter account. I'm not like the most active person on social media, but I would say LinkedIn is probably the best approach to find me.
All right. Yeah. Thanks, Fernanda, for your time. It was a pleasure to host you, and we wish you a great day forward.
Thank you so much, Jimmy. Thanks for having me. It was a pleasure to have this conversation with you.